Okay, Ling 341, we are back, and today we are going to talk about frequency, tone, and length. So, having gotten a sense of how fundamental frequency works or what it represents when we're talking about complex sound waves, like the kind of waves we get in speech, we want to see how that relates to different meaningful distinctions you can produce or perceive in language. So, those primarily for this lecture at least, we're going to focus on how that works in tone, lexical tone, and length or duration distinctions in language. I borrowed some of these materials from an old colleague and friend, Qilin Shi, so I want to make sure I thank her for this. But otherwise, let's just get into it. So I talked a little bit about suprasegmentals at the end of the last lecture, just as a reminder. Suprasegmentals are phonetic features of speech which are sort of above the segment. So you kind of have all these segments lined up in a row, as it were, and they can kind of bleed into each other as you go along. But superimposed upon what you're doing with your tongue as you produce various consonants and vowels, or what you're doing with your lips and jaw, so on and so forth. You're making changes in the fundamental frequency that you produce through voicing, and those can transmit information in language through the structures of tone or accent, or generally speaking, intonation. And then we can also talk about quantity, like producing some segments for a longer period of time than others, and then also stress, which is a fairly multidimensional sort of linguistic construct, which I'm not going to talk about today, but which I will get into in our next lecture. So this is the second time I've talked about suprasegmentals, and yeah, you can think about them as sort of like this contour intonation that goes on top of the segmental string of speech whenever you produce some sort of utterance in a language. They work a little bit differently, though, from segments. So generally speaking, with segments, you can say, well, if I'm going to make a bilabial stop, I'm going for some sort of specific target, which is to close my lips and stop the flow of air out of my mouth for a certain amount of time, and then move on to something else. Suprasegmental features kind of work like that, and the idea that you sort of string them along in an order, which is kind of maybe in tune, maybe out of tune with what's going on at the segmental level. But you can't define suprasegmentals with sort of like specific targets in the same way. Suprasegmental features, as I've got here, this quote from a famous suprasegmental features researcher, Ilse Lahista, from about 50 years ago now. She said suprasegmental features are established by a comparison of items in a sequence. So yeah, they go along in a sequence, and where they are is defined by what came before it in the sequence. So like if you produce a ba and you produce like an e right before it, like eb, something like that, the ba is going to basically be a ba regardless of whether it's an e that comes before it or an ah, so on and so forth. But with suprasegmentals, they're defined relatively. So what might be like a high tone can be determined by what came before that in the sequence. So if your frequency is a little bit lower, that high tone might be perceived differently than if the frequency is higher before that high tone. So we're not sort of targeting something really specific in terms of like frequencies or whatever. We're just making relative changes in the sequence, and that's sort of where the structure lies, basically. Those distinctions as we go along. Hopefully I didn't garble that too much, and I'll show you some examples as we go along, but try to remember that at all points, because we want to be able to relate this to acoustic phonetics. Now that we know something about acoustics, it can help us a lot because it kind of boils things down to like an objective reality. But suprasegmental reality is relative. It's not objective in that way. So it relates to something objective, but that's not what defines it, as it were. Okay, I'm not going to talk anymore about that for now. I'm just going to show you what's going on. So let's say we want to talk about tone or lexical tone in language. Where does it come from? Well, here's a waveform. Now that we know how to talk about these, this is me producing the vowel ah. We've seen examples like this before. It sounds like that. And we can see these spikes in the waveform. Each one of these is when my vocal folds open and close. There's a puff of air that comes through the vocal folds, and then it repeats the cycle many times a second, right? So I've got it listed here as the acoustic shock wave of each opening of the vocal folds shows up as a vertical bar in the waveform. Sometimes these are called glottal pulses. Sometimes these are called voicing bars. You can pick whichever one you like, but there's a way to refer to them. Actually, I'll show you as long as I'm thinking about this. I'll try to say the same thing here in prot. about the same frequency, I think. Yeah, so here is the waveform. And not too bad, right? You can see those glottal pulses or voicing bars here. I'm going to zoom in on them on the slides as well. But you see this little feature up here. There's a couple features I'll point out. There's a feature called pulses, which says show pulses. And I'm like, okay. So what Prot tries to do, if I turn that on, is it tries to sort of find where these peaks are, where these spikes happen in the waveform. And it does a pretty good job usually. So that's what these blue lines are when you superimpose those. So it's thinking of them as glottal pulses, as it's called. And there are other, now that we've turned this on, we can do other things with this, like get a voice report and so on and so forth. But I'll turn that off for now, and I'll turn on this pitch feature and say show pitch. And down here, you might notice in this, what we call the spectrogram view, there's a blue line now. And my pitch is not going to be exciting in this sample because it's monotone. Yeah, it doesn't change, but it gives me a reading of what that it thinks the pitch is. So I'll click on it down here, and it thinks it's about 122 hertz. Hopefully you can see that. Like I said, the average F0 fundamental frequency for an adult male speaker is about 120, and for me here it's about 122 hertz. So now you know, I guess, what that sounds like. I guess I'm pretty average, or at least that's what average sounds like. So I'll do this on the slide since I have this set up this way. But if we zoom in on that waveform, we'd see the same thing for in prod as we do here. That's where I got it from after all. When we zoom in, kind of like I did before, you see these individual glottal pulses. So same thing. Before I gave you an example of like creaky voice, like where you can kind of hear the individual pulses maybe separated from each other. You can't hear that in modal voicing because they're happening too fast. It's a little bit like that example I gave you of the different complex waves formed by, like adding 120 hertz plus 150 hertz. That gave us a fundamental frequency of like 30 hertz where we could kind of get a sense of like the individual pulses because that was such a low frequency. With creaky voice, it's such a low frequency you get that individual pulsing effect. But when you get to a certain point, your mind just kind of like strings it all together into one smooth flow. And you can't hear the breaks between them, but they're there if you look at it at a very fine, detailed acoustic level. If I move in even closer, I get this sort of look. So this is an individual glottal pulse in that same token I've played you about 2 million times now. There's another glottal pulse here, and there's another one here. I showed you an example last time of what sort of the waveform looks like when your vocal folds open, giving you the grotesque vision of what would happen if we took somebody's head off but left their larynx intact. That's how they would kind of open and close as you produce voiced sounds. Turns out that when you actually produce speech, and of course you don't take your head off to do it, thankfully. But what happens is that waveform gets even more complex because it has to go through sort of the filter of your vocal tract to get out into the outside world. So it looks even more complicated as we go. And it's clearly not a sine wave. I have the word sinusoidal here. That's what that means. It's not a sine wave, or doesn't really even look anything close to it. It's complex, right? It's got a lot of bumps and jagged edges and so on and so forth. But basically, what we're going to focus on for now is what the time difference is between one glottal pulse and the next, because that's going to let us know what the frequency of this creature is. So from going from this glottal pulse to this glottal pulse is the fundamental period of this sound. And if I know what the fundamental period is, I can figure out what the fundamental frequency is, because one is just the inverse of the other, right? So there's our period, and let's say frequency is 1 over the period. If I give you an example, we did this last time, but if the period is 0.01 seconds, then the frequency is what? And I'll let you think about that, or maybe just review that. But if my period is 0.01 seconds, and maybe I'll make this bigger, then my period equals 1 over 100th of a second. And that might make it a little bit easier. If frequency is 1 over the period, then basically my frequency is going to be 100 hertz. If I can repeat a cycle in 100th of a second, I can repeat that cycle 100 times in a second, basically. So one is just the inverse of the other. Okay, I think I've dwelt on that math long enough, though. I will give you an example here in my PowerPoint slide of what I showed you a second ago. This one's going to be a little more interesting. But when Prot has a feature, which we've seen, where it can measure what it thinks the fundamental frequency of a sound file is at any point in time. So yeah, I'll show you again how to turn that on because it will be useful to you as you do the tone transcription exercise. We'll go back to this, and remember it's up here at pitch. And if it's off, we get nothing. We get no blue line here. And if we turn it on and say show pitch, then we get a blue line. How fantastic is that? And I'll show you one other thing here. You can change the pitch settings. So you can say, well, I'm going to assume the lowest pitch I can get is like 100 hertz. For a male speaker, you might actually want to go a little bit lower than like that, like 75 hertz. And maybe the high end would be more like 300. And maybe this blue line bumps out a little more obviously when I do that. Like that. But it's still at about 120 hertz or so. You can read it over here. And this tells you what the range is on the right-hand side. For a female speaker, we'd expect to have relatively higher fundamental frequency, a relatively higher pitch. I'm going to use those terms relatively interchangeably, even though they're not exactly the same. Frequency is acoustic, pitch is perceptual. But what this pitch track or frequency track shows you is time on the x-axis and then how fundamental frequency changes on the y-axis. And it shows it in this blue curve going along here. So this is a female speaker saying,
I'd like to collect seashells this afternoon.
We'll try that again. Yep.
I'd like to collect seashells this afternoon.
So you can hear it a little bit better. Again, I've set the lower end of the range at 75 here, and the higher end is 500 hertz here. So her F0 kind of goes to its maximum peak on the word like, and I don't know, that's maybe like 350 hertz or something like that. But you can hear it jump up to that, and then it kind of like consistently goes down. Maybe bumps up a little bit on C until it goes down to the very bottom of her range at the end of the utterance.
I'd like to collect seashells this afternoon.
Right. So that's what Prot is measuring, and it's a nice sort of acoustic visual record of the acoustic phonetics going on here because we sense it. You know, you perceive F0, you can tell, well, this is a higher pitch than that, but you don't know exactly how high it is. And for us, if we're English speakers, we're used to listening to sort of like, well, that's like sounds more prominent because it's up there, higher in frequency. But
I'd like to collect seashells this afternoon.
We're going to listen to some tones in languages we may or may not speak. And since tones are implemented on a word-by-word level, we're not used to listening to that. And so looking at these pitch tracks will help us try to interpret the differences between those tones if we're not native speakers or fluent speakers of that language already. Okay, so just so you know, Prot has that automatic pitch tracker. I can show you, I guess, a little bit of what it looks like when I produce the same utterance. I'd like to collect seashells this afternoon. I don't know how good that was, but who cares? So this is my seashells, and we can listen to my little garbled bit there in the middle. Yeah. I'd like to collect seashells this afternoon. Great. Anyways, so you can see here's my little peak here for I get up to about 213 hertz, so not nearly as high as the female speaker did. Also, I want to point this out in case it's not already obvious, but if I have a voiceless segment like this C, this S and C, it's not going to record pitch for that, right? It will record pitch in anything voiced, like the E after it, but not in a voiceless segment. So that's why it has these gaps in it, and you kind of have to interpret through those. Seashells this afternoon. Okay. Anyways, like I said on the slide, it can be messed up by voiceless sounds. It's not really messed up. It's not going to record pitch in the voiceless sounds. And then like stops and fricatives and affricates kind of tweak what's going on a little bit because it finds it hard to read pitch in something that sort of goes by quickly like that. So just watch out for that and be aware it's going to happen. Sometimes the pitch tracker can double or have the correct fundamental frequency. Yeah, and I'll show you like where that's likely to happen. Like this is me. I like to collect seashells this afternoon. So my highest F0 here goes to about 213. So let's say I lower the upper end of the pitch range to like 200. And so remember, this starts at a 213. And So it can actually go up to 213 because the limit now is 200. So this should be about half of what it was before, about 106, 107. So that's just a artifact of setting the pitch range wrong. So be careful about that. Try not to make it too narrow for your speaker. For a male speaker like myself, 75 to 300 is pretty good. For a female speaker, I'd say 100 to 500 is a pretty good range. But sometimes people go to extremes and go beyond that. Yeah, so we learned the technical reasons why that happens in 441 if you want to keep going and learn why. But otherwise, this pitch tracker works well, so I want to encourage you to use it. That's why I'm talking about it so much. It will make your life easier as a transcriber of Suprasegmentals, basically. Yeah, so I mentioned tone. I'll mention it again because it's what we're gonna talk about now. But tone is the linguistic use of fundamental frequency to signal important differences in meaning. And here's that breakdown that I was alluding to before. But at the acoustic level, we're talking about frequency or fundamental frequency, just simply how many times does something repeat in like objective acoustic reality. And if I'm listening to different frequencies, I can judge whether one sounds higher than the other. When I'm doing that, we refer to pitch, what frequency gets translated into in the perceptual domain. But then tone is a linguistic construct. So tone signals meaning. And it is based on these different frequencies or these different pitches. But like I said, it's always going to be relative. It's not like the tones correspond to specific frequencies that are being produced out there. Generally speaking, we'll find that they're either like higher or lower than other tones, or they're exhibiting kind of a certain pathway through the frequency range of a speaker. Okay, so 3 different sort of levels of how periodic sounds get used or can be analyzed using these frameworks we're talking about: acoustic, perceptual, and linguistic. Let's just focus a little bit on the linguistic part of this for now, having these sort of as our foundation. So English, I've got a little joke here. It's funny for me. English is a tone language, not really, but sort of. You can get it to kind of sound like a tone language if you boil a whole utterance down into like one individual like word or sequence of segments. So I had a student a while back who did an honors thesis. I think it was actually 2009 now, and it was kind of fun because he wanted to look at how people perceive these sorts of tone contours, I guess you could say. So I'll just let you listen to them, and you can tell me what you think. Mm-hmm. 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 Right. So, yeah, that's just the expression "mm-hmm," which isn't really a word. It's sort of like maybe it's affirmative, maybe it's negative, or maybe it's whatever. And with different fundamental frequency contours superimposed upon it, it seems like it's meaning different things, or the speaker's trying to get different ideas across. Mm-hmm. Mm-hmm. Yeah. So English is not really a tone language, but it does change F0 to sort of signal differences in meaning. I will give you kind of a breakdown of what you can sort of expect to find in language with respect to how it implements F0 in utterances. So F0 is generally going to vary in 3 different ways in language. And actually the primary way is a way that English does not do it. It's using tone in tone languages. And some classic examples of this, a classic example of this is the Chinese languages like Mandarin or Cantonese. And I'll give you examples of tone in both of those languages as we go. But there's lots of others like Navajo, spoken in the American Southwest, or Igbo, spoken in Africa. And what goes on in these languages is that you have a lexically determined tone on every syllable or word. So you can't just pick and choose to put some contour on any given word at any given time. You have to produce a specific word with a specific F0 contour or level. Anytime you produce it, that's just part of how the word is pronounced. And like I said, the majority of the world's languages have this system in their phonological toolkit, as it were. It's part of the phonology of the language. So the other languages, which are in the minority, are either pitch accent languages. Some examples of that are like Japanese or Swedish. And former TA for this class spoke Serbian. Serbian's another language which does this. And I believe Blackfoot, which is an indigenous language spoken in the neighborhood, also does this as well. But basically, instead of having a lexically determined tone on every word. What you have is an accent in a particular word, which is lexically marked. So you could have a word, say, with more than one syllable, and then one of the syllables might have an accent on it, or not, right? But you don't have to have an accent on every single syllable, which is more like the case in Chinese. And I guess I'll say that Chinese, like languages like Mandarin or Cantonese, they like everything consists of individual syllables, and you can combine them together and to make bigger words. But basically, there's a tone on every syllable, and a syllable can be a word by itself. So it's a little bit different here. I also mentioned that there are stressed languages. English is an example of that. Russian is another, so on and so forth. And I'm not going to get into that today because it's pretty complicated how those work, sort of like a relationship on Facebook. But we can talk about that next time and kind of dive into it once we understand how intensity works a little bit better. So before I move on again, I just want to sort of try to make this distinction clear. Pitch accent languages, you're also going to get changes in F0 for accented versus unaccented syllables or words, but they don't have to be on every single syllable or word. You can have unaccented things, but in a tone language, every single syllable has a tone. Okay, so like I said, Mandarin is a classic example of a tone language. It's the most widely spoken language in the world, and it has 4 different tones. And what goes on here is basically you're trying to produce like an F0 pattern with each syllable. So this first one is at a relatively high part of the speaker's range, and it stays there throughout. The second one starts in kind of a midish position, kind of dips down and goes up a little bit. The third one starts in the middle and goes down, and the fourth one starts high and goes down. And you should be able to hear this, even if you're not used to listening to syllables like this. It's there, and then the fun part of it is that these tones alone are going to signal differences in meaning. So I'm going to show you or play to you how these go along with the syllable ma. And there are 4 different ways to produce that syllable ma. The first means mother, the second means hemp, the third means horse, and the fourth means scold. So here we go.
Ma, 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 ma.
Right. So that's kind of fun. Usually in class, it's fun to sing along as well. So I might as well give it a shot here, and you can do the same thing at home.
Ma,
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 ma. So I actually did a bad job on that. I'm going to do it again.
ma,
Ma. So the trick is, like when I did that the first time,
ma,
I tried to match her F0.
ma,
Ma. And that is not what you want to do. You just want to stick that tone sort of in the higher end of your range.
ma,
Ma.
ma, ma,
Ma. And then that's your variant of that tone. So I don't have to like sing it as high as a female speaker would because it's not about the specific frequency. It's just about this pattern in that part of my range. Let me try this one again.
ma,
Ma. Something like that.
ma,
Ma.
ma.
Ma. Yeah, I'm not a speaker of Mandarin. There are Mandarin speakers out there making fun of me right now, but it's okay. That's the idea, is to kind of just adjust your range to get the appropriate tone. Another fun part of this is that given this set of words, you can string them together in a way that makes them into different sentences. There's also a ma with a 0 tone here, which is kind of just a syllable that takes its tone from the surrounding tones, basically. But I won't dwell on that. I'll just play these sentences for you. They mean the exact opposite of each other.
Mama, mama. Mama, mama.
And you can sing along at home to these too.
Mama, mama.
Mama, mama.
Mama, mama.
Mama, mama. Yeah, embarrassing myself further, but that's kind of the idea. And you have to pay attention, right? So if you're speaking in a language like this, you can no longer just assume that, what the F0 is doing is something sort of ancillary to the message the speaker is trying to produce here.
Mama, mama.
You have to listen to it. You have to produce it yourself. That's the way tone languages work. So I'm going to make this point again. Tones are defined by the pattern they make through a speaker's frequency range. And the frequency range is usually assumed to encompass 5 levels, or at least that's how it's transcribed. And that can vary depending on the language. So let's say we're thinking about any given speaker's frequency range. At the bottom level of their F0 range, we have like a 1. At the highest level, we have a 5. And these are not specific frequencies. It's just relatively high, relatively low. And then you're kind of have the options of going through these 5 different levels as you produce the tone. So I'll show you how that works with these Mandarin tones.
Ma, 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 ma.
Right. So this first one is that high level tone, and there's a couple different ways to transcribe it. So it's given the traditions of the study of Chinese phonology. Each tone is associated with a specific number. Like this is the first tone, and like anybody who's studied Chinese or Mandarin just knows that. But I don't want you to kind of refer to these as with these tone numbers because they're kind of arbitrary. It's easier to talk about them like this is the high level tone, or even better yet, you can say this is the 5/5 tone because it starts at the high end of the speaker's range and stays there.
Ma.
There are also this notation. These are called the Chow tone letters. So this vertical bar is supposed to represent the frequency range for a speaker from bottom to top. And then what goes to the left of it is basically the sort of tone contour that the F0 contour that the tone makes as it's produced. So this one starts high and stays there.
Ma.
This one starts in the middle and goes up. So you can either represent it this way with the Chow tone letter, or you can say it starts at 3 and then it goes to 5. Starts in the middle, goes to the top.
Ma.
This one starts at 2, goes down to 1, goes up to 4.
Ma.
Maybe. And this one starts at the high end 5 and goes all the way down to the bottom.
Ma.
And there are also, it turns out, kind of subtle like duration differences.
Ma.
That one may be a bit longer than
Ma.
that one, but that's the idea. And I think this one shows it best. Like it starts at the high end 5 and it goes down to the 1 at the bottom.
Ma.
But it's not like it's going to a specific frequency, like 300 hertz to 100 hertz or something like that. It's just the high end of that speaker's range to the bottom. And every speaker's range is different. So I've got this little note here at the bottom about each syllable can be labeled with a tone number, like this is ma tone number 1 or ma tone number 2. And I will actively discourage you from doing that. I would like you to do this sort of transcription for these guys and just say label basically the path it takes through the frequency range for that speaker. So if I see this transcription ma for a ma with a 5/1 tone, then I know you're going from the top to the bottom. Try to use this, and if you want to study Chinese, go right ahead and learn the tone numbers too. But for our class, we'll just think about this in terms of the relative height or level of the frequencies that are being used for the tone. Okay, so making the same point for the millionth time, but tone is relative. It's not absolute. Each speaker has a unique frequency range. So if I have a male speaker, my highest or higher F0 might be around 200 hertz. My lower F0 might be around 100. For a female speaker, her high end might be around 350 or the low end might be 150. But these will shift up and down from speaker to speaker as well. You're not trying to target a really specific frequency when you produce these tones. It's just higher versus lower. So I'll give you an example of how this works kind of across the genders here. So the same tones may be denoted by completely different frequencies depending on the speaker and whether they're male or female. So here's the high level tone for both a female speaker
Ma.
and a male speaker.
Ma.
Mom. I'm singing again there, but that's more in sort of an appropriate frequency range for a speaker like myself. It's the same word, same meaning, same tone.
Ma.
Ma. But the acoustic phonetics are different. Excuse me. So tone is abstract, right? It's not something that boils down to some specific frequency at the objective acoustic level. And the same thing works for the tone or frequency range as well. So this got messed up a little bit because the pitch tracker broke, but this is the female speaker again with her 5/1 tone.
Ma. And
the male speaker with the same tone.
Ma.
So he's only going from this level down to this level. That's a lot less of an absolute acoustic frequency range than the female speaker who can go from this at the high end to this at the low end.
Ma.
But it's the same tone.
Ma.
Right? So you always have to think of this in a relative fashion according to the speaker, according to whatever range they happen to use, not some sort of specific absolute frequency. Okay, So I want to draw a distinction here between what are called level tones and contour tones. So Cantonese is a good language for this because it has 6 tones. So yeah, here's the fun thing about Chinese or the Chinese languages. They're all written the same way because they have this cool writing system that has individual symbols for different words or syllables. Cantonese, which is spoken sort of in the Hong Kong area, and then Mandarin, which is spoken, well, sort of the more official, more widespread language of China. They're not mutually intelligible, at least not in their spoken forms, but they're written the same way. But Cantonese is completely different from, well, not completely, but it's very different from Mandarin. For instance, it has 6 tones rather than 4. And believe it or not, the speakers of these languages kind of get into a bit of a rivalry about, well, my language is better because I have 6 tones, not 4. But whatever, we'll just leave that to human nature. And the point I want to make here is that there's different ways of describing the kind of tones you get in lexical tone languages like this. So a level tone is like that 5/5 tone that we saw in Mandarin that just stays in one specific frequency range throughout. And then you can also get contour tones, which change their level during the production of a tone. So there are 3 level tones in Cantonese, and there are 3 contour tones. I'll play them all for you, superimposed on the syllable C.
C.
I'll make that a little bit quieter. And again, it's fun to kind of try to sing along with these.
C. C. C.
So that's just going down in frequency, and then these move around.
C. C. C.
Yeah, so there are 6 of them. I'll play them again.
C. 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 C.
Yeah, many years ago, kind of a funny story. My first year of grad school, we were supposed to go out and find a language that we didn't speak and learn how to transcribe it from a native speaker of that language. So I found a speaker of Cantonese, which I'd never encountered before, and spent a semester just transcribing different words in the language. I think the speaker thought I was a little bit crazy because I never cared about like learning how to actually say anything myself. I just wanted to write down everything he said, which is not what normal people do. But I learned something from that because I knew Cantonese was a tone language going in. And I was trying to sort of decipher the tones without consulting any references or grammars about the language. And I figured out through the course of the semester that it had 5 tones, but I didn't realize until later afterwards it actually had 6. So these last 2 are pretty similar.
C. C.
And I never really learned the difference just by listening. But there is actually interesting things going on. Some younger Cantonese speakers apparently kind of merge these.
C. C.
Maybe that's an example of getting close to a merger there. So the tone inventories of a language can change over time, just like anything else in the phonology of the language, right? Yeah. So I'm going to give you some examples of other kinds of tone languages that only have 2 or 3 tone targets. And these are called register tone languages. So these will transcribe as having sequences of like high tones and low tones rather than like 5/1 or 2/3 or what have you. And it's also possible to have midtones in languages like this. So just so you know, the way these are transcribed in the IPA system is that a high tone is going to be this little accent mark pointing up to the right, and a low will point down to the right. I think if you took 201, you probably learned to transcribe stress like this, but that's why we don't transcribe stress like this in the IPA, because we have that. This is reserved for tones, and so instead we use that vertical strike mark before a syllable for stress. But yeah, in these languages, tone also makes differences in meaning, so it can be used for grammatical markers like tense or possession or so on and so forth. I'll give you some examples. This is from a language called Ibibio, which is spoken in southern Nigeria. It has these labial velar stops, which are kind of fun. So watch out for those. But this is like a sequence of 2 high tones. And this is like a sequence of 2 low tones pointing down to the right there. If you have a high tone followed by a low tone, you get a falling tone in this language. And that's represented by a rising and then a lowering diacritic here. So I'll just play these, and I think you should be able to get a sense of how the F0 is changing for each. Maybe I'll make that a bit louder. So that's two high tones. Here's high followed by falling. Here's high followed by low. Right. And then we have a low tone followed by high. Low followed by falling. And a low, low. Right. So I think that's fairly straightforward. You'll see some more examples of that in the transcription exercise as well. But that's basically how the notation works. And hopefully the examples in the transcription exercise will help you out with that as well. I mentioned pitch accent languages. And again, the difference here is that in a pitch accent language, you're not getting a specific tone contour associated with every syllable or word, but you would get one pitch accent associated with each word. And the pitch accent will be realized on only one syllable in the word, and the other syllables in the word can have no accent. Like in a tone language, accent is going to be lexically determined, so there can be minimal pairs. And that's kind of the big crucial difference between how these systems work and language like English works. In English, you're just not getting this information from the lexicon. You don't have some information saying, well, I have to produce the word window, like window or something like that. We have stress instead, which involves frequency, but it's more complicated than that. So just set that aside. In English, we can kind of, produce window with different frequency contours like window or window, depending on other factors like pragmatic factors rather than lexical factors. But in tone languages and pitch accent languages, this information is going to be lexically determined. So when you produce the word, it has to be produced in a certain way. Simply like determining what segments to use for a specific word is determined by the lexicon in English or basically any other language. So I'll give you an example of Japanese being a pitch accent language. This holds for not every variety of Japanese. It turns out there are dialectical differences in the language depending on where you are in the country, I guess, of Japan. And then there's also, this works for some but not all words. So I'll just give you an example of one variety of the language where it works. So in this variety of language, in this variety of Japanese, words have one high accent, and it attaches to one mora in the word. And normally when I talk about this in class, I kind of walk through, I've got an example here, what a mora is. So a mora is a vowel or a consonant following a vowel within a syllable. So a consonant in the coda position, as we call that, and I'll talk about that more next time too. I don't know much Japanese, but I know the words for 1, 2, 3 are ichi, ni, san. So ni is the word for two. That's only going to have one mora. It's in phonology you call it a light syllable because there's no coda consonant. So there's our one mora, but san has two morae or moras if you prefer. So a is one mora and then n is the next mora. So there's two in this one syllable. It's kind of a fine distinction between the mora level and the syllable level of phonology there. But either way, the accent in Japanese is going to attach to a mora, not a syllable. I haven't made a that's a mora joke yet, but I might as well get it in there as long as I'm recording this. Anyways, so the way it works, the way the system works in Japanese is that the first mora, if not accented, has a low F0. And then morae following the accent have low F0. So at some point, there's going to be a high point in the F0. It could be on the first mora. It could be somewhere after that. But basically, anything after that is going to be low. And if the first mora doesn't have that high point, it's going to be low as well. So I got this information from this website. I haven't checked to see if it's still around because that was a long time ago. But it's out there in the world of what we understand about phonology. Here are some examples of these distinctions between a word like morning, asa, and hemp in Japanese. I don't know why multiple examples of these refer to hemp, but there you go. Anyways, this one has the accent on the first mora.
Asa.
And this one has the accent on the second mora.
Asa.
Right, so this one is an accent. It starts low, and then it goes high for the accent on the second mora.
Asa. Asa.
And then I have a 3-syllable or 3-mora sequence here, hasinga, which means 3 different things depending on where the accent is. So accent on the first mora here.
Hasinga.
Accent on the second mora.
Hasinga.
And then accent on the third mora.
Hasinga.
Yeah. So This one winds up being a little bit different because we get a high on the middle one there too. So it's a little bit complicated, but you can hear the difference basically.
橋が、橋が、橋が、
Yeah. So basically, again, we only get like at the acoustic level F0 differences between these guys, meaning different things in the language. But the system itself, although it is determined lexically, it works in a slightly different way from tone languages because it's not like every single syllable has to have some specific contour of F0. That's an accent language rather than a tone language. Lastly, today I want to talk about length distinctions. So these I think are relatively easy to understand because all they're talking about is like differences in whether a segment is short or long, basically. The way we refer to this in phonology or linguistics is we say it's a quantity distinction. So there's also a three-way breakdown we can talk about here. Like if I'm talking about time at the acoustic level, then I'm talking about duration, like is this 100 milliseconds long or 200 milliseconds long, so on and so forth. If I make a judgment, if I hear different lengths of segments or what have you, at the perceptual level, then I'm talking about length. And then linguistically, like I said before, we're talking about quantity. How much of something do you have? Is it a long segment or is it a short segment? And these are not exactly lined up with each other. At the quantity level, it's going to be relative as well. So a long segment will be relatively longer than a short segment, but it's not going to be some specific amount of milliseconds longer than a short segment. This also is relative too, right? Depending on who's speaking. So I think we all know some people speak more quickly than others. In these videos, I speak relatively quickly to get the information out. But normally I'd probably speak a little bit lower. And so it depends on speaking rate too. So sometimes you might want to speak faster than others, but you're still going to make relative distinctions in length to get these sort of linguistic distinctions across to your listener. Okay, so here's some examples from Danish, which has long and short vowels. So I'm going to focus on these two columns on the right here. So the way we transcribe this in the IPA, this has a long E in this word. Actually, I'll play these distinctions here to start off with.
Ville, ville,
And you can hear the E here is longer than the E here.
ville, ville.
So the way we transcribe that, I mentioned that before, is with a colon diacritic, or maybe those two triangles pointing at each other would be more appropriate. But that's all that's being shown here, is that these guys are a little bit longer than these, and it makes a difference in meaning.
Mene, mene,
And that difference in meaning is the thing we don't find in a language like English, right?
læse, læse, masse, masse.
Yeah, this one's kind of interesting. So normally this vowel in English is produced relatively as a short vowel because it's lax in English.
Læse,
That's part of like how it distinguishes itself from A. There's both a quality distinction between A and E and a quantity distinction between A and E because our A's are a little bit longer than our Es. So in Danish, those two distinctions are independent of each other. You can make the E longer, and when you do, it sounds a little bit more like an A in English.
læse,
So this one might sound more like an epsilon,
læse,
and this one might sound more like an A,
læse.
just because it's longer, right? And that's how you transcribe it, either way. So I've got that exact same example here on this slide, but the vowel in the first one,
Læse,
you can measure it in prot. This is the waveform for both tokens, but the length of that vowel is 150 milliseconds, and the length of this guy, the long one,
læse,
is 275 milliseconds. So it's pretty clearly longer than this one, but it's not like it's exactly twice as long, and you don't really have to think about it in those terms either. So this could maybe be like 250 or 260. It doesn't hit an exact number. It just has to be longer in some noticeable way for this to be a longer segment or a long vowel rather than a short vowel. Everything in the suprasegmental world, again, is defined relatively, according to the speaker, according to the context, according to differences between high and low, differences between short and long. And I've kind of run out of gas with my vocal folds here, so I'm just going to wrap it up with this Italian slide. So Italian's fun because it has both long and short vowels and long and short consonants. So these kind of interact with each other a little bit here, but I'll play some samples of these, pointing out as I go that Italian has palatals. It has palatal laterals, which are transcribed with this symbol. It looks like kind of an upside down Y, or a backwards lambda if you prefer, if you like Greek. And it also has palatal nasals, which we've seen before, but those are these guys. So yeah, some of these are going to be short, some of them are going to be long. Here are some short laterals.
Li,
And some long laterals.
folla.
Here's another short one.
Velare.
Actually, I'll do this one as well.
Gli, foglia.
That one's a little bit longer
Foglia.
than that guy.
Gli.
And this is a long alveolar L, and this is a this is a short alveolar L, and this is a long palatal lateral.
Velare. Vegliare.
And then we have short and long vowels here. So this is a short O in the beginning and a long O for this one.
Nonno, nonno, nomi.
And then
Sogno, gnomi.
yeah, like that. And either way, this is transcribed kind of the IPA appropriate way with these two triangles pointing at each other. But that's basically how quantity distinctions work in language. Like tone or accent differences, they're defined. They're specified by the lexicon, and they're defined in a relative manner as either just longer or shorter. And that can correspond to different actual specific durations in terms of milliseconds, as long as you get that relative distinction across. Okay, I mentioned at the beginning of this lecture that stress is another suprasegmental feature that's more complicated than these guys. So we're going to address that specifically in the next lecture and also talk about intensity too. So that's what we have to look forward to, and that is the sort of primary lexical suprasegmental feature that gets applied to words in a language like English. So we'll look forward to that. And otherwise, hopefully this information will be useful to you as you complete your transcription exercise. All right, have fun.